welcome everyone to the Tulsa.NET user group. Tonight we got Dan Roth talking on Blazor.NET 8. We got some great stuff that has just been released. Dan, thank you for coming out tonight. It's great to have you here. I really appreciate it. I got to meet you at Build. What was it, April or May? I don't remember which, but it was the last Build.
Yeah,
and I finally got to, I got to stop you and twist your arm for a little bit. So I'm glad that we finally worked out some time to get you to come visit the user group. I'll let you take it from here.
Great. Thank you so much. It's great to be here. Thanks for having me. It's great to see all your friendly faces on the call. I'm Daniel Roth. I'm the product manager for Blazor on the .NET team. And so today, of course, we're going to be talking about Blazor, specifically the new features in Blazor in .NET 8, the support for building full stack web UI using Blazor in the .NET 8 release, which we just shipped in November, and it's been going great. It's been really fun to hear about people's experiences trying out the release and upgrading and using all the great new capabilities. I'm here for you guys, so if you have questions or commentary, like feel free to put those in the chat or just go ahead and unmute your mic and ask away. Feel free to interrupt. So I want to make sure I get your questions and curiosities satisfied. So feel free to ask questions as you see fit. But to kick things off, I thought it'd be good just to level set about what Blazor is all about. What is this Blazor thing? What should you use it for? Blazor is our front-end web UI framework for .NET. Blazor is designed so you can quickly build interactive web experiences entirely using .NET and C#. It's part of ASP.NET Core, which is our umbrella web framework for .NET, and it all ships as part of the .NET platform. If you have a modern .NET installation on your machine, you've got Blazor, and that's been the case all the way back to .NET Core 3.0. That's when we shipped the first Blazor version in the box with .NET Core 3.0, and we have shipped with Blazor with the .NET platform ever since. So not so new anymore. Blazor has really matured into a fully featured front-end web development solution. Blazor is based on a powerful reusable component model that you can use to easily handle UI events, render updates, and set up two-way data bindings. Blazor comes with many built-in components for doing forms and validation and displaying large virtualized data sets. There are also many readily available Blazor component libraries from the community, including a library of Fluent UI-based Blazor components that we ship from Microsoft. You can use the latest open web standards with Blazor. Blazor is based fully on open web standards, so you can use it to build progressive web apps that are installable and that work offline. We provide rich tooling for Blazor in both Visual Studio and in Visual Studio Code, including support for hot reload. And while you typically write your Blazor apps using C#, you can also interoperate with existing JavaScript libraries if you need to. From your C# code, you can call into JavaScript, and from your JavaScript code, you can call back into C#. Questions? Okay, just people saying that you can ask questions. Now, in .NET 8, we've dramatically expanded Blazor's capabilities to leverage the best of the server and client when building web user interfaces. Modern web apps these days, they often need to use a combination of approaches involving both the server and the client to deliver the UI experience for your users. For example, many web apps dynamically generate static HTML from the server in response to requests. And this is often called server-side rendering, or SSR. Server-side rendering helps your app to load really fast because you're doing all the hard work using the server. You're prefetching the data and deciding how to display it. It's already done from the server, and then all the browser needs to do, all the client needs to do is to display the already rendered HTML. So it's dynamic in that you're generating HTML from the server. It's static in the sense that once the HTML hits the browser, it's just, basically static content. Now, .NET has long had support for building server-side rendered web apps with frameworks like MVC and Razor Pages, and even older frameworks like ASP.NET Web Forms and so on. Now, server-rendered HTML is by its nature static. There's no code running on the client that can handle user interactions, like hook an event handler for a UI event. So if you really want rich interactivity in your web application, then you're generally going to want to handle things from the client. And for that, you need client-side rendering, or CSR. By rendering from the client, you can have very low latency UI interactions, and you can leverage client capabilities like local storage, the camera, local compute, and so on. For client-side rendering with .NET, we have, of course, Blazor. Blazor's component model is designed for handling UI interactions from the client. Now, many modern web apps actually need to use, a combination of these two approaches. There's lots of debates on the web about, oh, you should do server-side rendering. Like, no, you should do client-side rendering. But the reality is many apps actually need to use both. So, for example, maybe your homepage or your blog is best handled using server-side rendering so that it loads really fast. You don't have to sit and wait for a large JavaScript bundle to be downloaded and executed. It makes the page easy to index. But more elaborate functionality in your app, that needs to be more interactive, that maybe needs to be handled from the client. So blogs, content, maybe better handled from the server, lots of interactivity, better handled from the client. Now, previously with .NET, if you wanted to do both of these things together in the same app, well, that usually meant you had to mix multiple different frameworks together. Like you would take MVC and Razor Pages, and then maybe also use Blazor for the client-side part, or maybe use a client-side JavaScript framework like Angular or React. But in .NET 8, what we've done is we've tried to combine the benefits of both server and client-based rendering into a single consistent web UI framework based on Blazor. You can now use Blazor in .NET 8 to handle all of your web UI needs. You can use Blazor components to render HTML directly from the server, and you can also enable rich interactivity using either the Blazor Server or Blazor WebAssembly based models, or even both from within the same app. So Blazor in .NET 8 supports full stack web UI development, both the server and the client. Let's see if there's any questions. Let's see any questions. Gonna move on. Okay. So what does that really mean? What does that break down into? So full stack web UI with Blazor in .NET 8 really breaks down into 5 new areas of investment, 5 new capabilities. The first is static server-side rendering support with Blazor components. Then on top of that, we've added a couple of progressive enhancements on top of static server-side rendering by just adding a little bit of client capabilities, including enhanced navigation and form handling and streaming rendering. You can then also add full client interactivity at a very granular scope. You can do it per component or per page. And you can do that not just like statically, like as part of building your app, but you can even decide how you want components to render at runtime by automatically selecting which component render mode you want to use at runtime, so you can further optimize the page load experience. And what we're going to do is we're going to take a look at each of these 5 different areas. Right? Okay, so first, static server-side rendering. So if you've used .NET frameworks like MVC and Razor Pages or Web Forms, then you're probably already familiar with static server rendering-based frameworks. Static server rendering means generating static HTML in response to a request from the server. Static server rendering with Blazor means that you route a request to the appropriate Blazor component on the server, and then it just renders HTML to the response, and it's done. There's no WebAssembly involved here. There's no WebSocket connections. You just get static HTML rendered to the browser in response to requests. Note that this is different than Blazor Server if you've used Blazor in the past. In a Blazor Server app, the components also render server-side, but there's a persistent stateful connection with the browser, usually a WebSocket, that can be used to handle UI interactions. So Blazor Server, we would call that now interactive server-side rendering, not static. In traditional server-side rendering, the connection just lives as long as the request, and the app is typically stateless, whereas a Blazor Server app is stateful and is fully connected. Okay, so this is different. Not Blazor Server. This is a new thing, static server-side rendering support. So what does this look like? So let's hop over here to an application. This is a recipe application that we've actually shown for quite a while. I think I demoed this app back when we shipped Blazor WebAssembly for the first time. But this is a new version of the recipe app. Let's go ahead and get it up and running. Okay, so we have a simple recipe page that we can browse a long list of recipes. We can search for recipes, chocolate ones, and there's our chocolate recipes. We can pick one, see the recipe details, and then learn how to make it. And then there's a little review widget down here at the bottom where we can give it a 5-star rating. Now, what's new and interesting about this Blazor web app is that it is just using currently static server-side rendering. There's no client-side based interactivity being used in this app at all. And we can see that by just bringing up the source for the page. Like here's the rendered HTML that came down from the server, and it is literally just plain old HTML. No JavaScript, no WebSockets, no WebAssembly, nothing fancy like that. If we bring up the browser DevTools, and let's remove all the filters and bring up the network tab, and let's just let's just refresh the home page. You can see what's being downloaded to render this home page for the app. If we now filter on WebSockets, I'm going to click on this little S filter to just see if there's any WebSockets here. There are no WebSockets in this app. I feel like I'm a magician. Nothing up the sleeve, nothing up the, no WebSockets. Is there any WebAssembly? No WebAssembly. Is there even any JavaScript? There's no JavaScript in this application. It is all being statically rendered from the server. And that means that the app loads fast, it's ready to scale, it's stateless, easy to index, all those nice characteristics by leveraging the server for the UI for your application. All right, so that's the rendering. And this can, you could do some interactions with this, right? Like you saw, we could do a search. Like this is a form. It's just a normal HTML form that's doing a GET request. Let's do a different one, like straw. Do we have any straw recipes? Apparently we have straw and hay fettuccine tangle. So for all you people who like hay flavored fettuccine, you can have some hay flavored fettuccine. But there's that little widget at the bottom, the reviews widget. This is also a form, love the hay flavor or whatever, submit that. And that does a form post and then adds the review to the bottom. Okay, so we can do basic form requests as well. So what does this look like in the code? Let's go to Visual Studio. And let's bring up like the home page where we're seeing all those recipes being generated. This is just some simple Blazor code, and nothing really fancy going on here. We have a little recipe store that we're using to get the recipe data. We have that form at the top for the search, and it is literally just a vanilla form. And then we have this for each loop where we're looping over all of the recipes that we got and then rendering a recipe card. So just doing all that rendering from the server in response to a request. What about the that little star rating reviews component? That's over here in this Razor class library. So here we can see that we're using the built-in Blazor edit form component to implement the form for submitting star rating reviews. And it's using the normal programming model for a Blazor form. If you haven't used Blazor before, this might be new, but this edit form is just going to render a HTML form under the covers, but it's allows you to do things like specify a model type and have validation run on that form. And that's all going to happen on the server in response to a request. And then it will render a normal HTML response. So just plain old vanilla HTML forms, but now done with Blazor components, done within the Blazor component model. Okay, so that's how.
And you get that for free without any kind of rendering model?
That is for free. I mean, you have an ASP.NET Core app, and you tell your ASP. Yeah, let's look at the program CS file. Like this is the program CS for my what is fundamentally an ASP.NET Core web application, and all we're doing here is just setting up our Blazor components as like map Blazor components. We're setting them up as normal ASP.NET Core endpoints using endpoint routing. So
but I guess my question, Dan, is without any interactivity, without WebAssembly or
that's right. Circuit. No you saw in the networking trace, there was no WebSockets, there was no WebAssembly being downloaded. This is just like as web apps were built, 10 years ago, right? Like it's just server-side rendering of HTML. A request gets sent, run some .NET code, send a response. Yep, cool. All right. So that's static server-side rendering. And that Blazor will just do that now by default. But we can start to make that user experience better. Like we can start to enhance that user experience by just adding a little bit of client-side logic, a little bit of client-side enhancements. And there are a couple of these enhancements that we add. The first one that I want to show you is enhanced navigation and form handling. And what this is that Blazor will, instead, like normally when you do a page navigation, like you click on a link in your app or you on a tab or whatever, it will do a full page load, right? It'll do a full page navigation, grab the HTML, grab all the links, pull down any CSS, JavaScript, and images or whatever it needs in order to render that page. And for this reason, server-side rendered apps have this a reputation of being a little bit jarring. Like every time you navigate, the page kind of blips and then reloads. Like it doesn't have that smooth feel that like a SPA JavaScript-based app does. But we can get a little closer to that by just adding a little bit of client-side logic with our Blazor web app. What we can do is when a user navigates, we can intercept that navigation and instead have Blazor do a fetch request. You don't have to write this code. Blazor does it for you. The Blazor does a fetch request, retrieves the server-side rendered content from your server, and then figures out on the client, well, okay, what changed here? What's in the DOM currently, and what did I just get from the server? And then Blazor can patch up the DOM with the new content without having to do a full page load. And what that enables is a much smoother navigation experience. And you also get to preserve state in the DOM without just blowing it away and having to recreate it every single time that you navigate to a new page. Very similar pattern with form handling. When you do a form request, Blazor can intercept that, get the server-side rendered content from the server, and then patch up the DOM seamlessly. Let me show you what I mean. So right now with this app, as I navigate around, you might even see like the tab kind of blips a little bit as I like click on things. That's because every time I navigate, it's doing a full page load. Like if I remove all my filters and let's do a click here, you can see that request to pull down recipe number 1 was a document style request, right? So pull down the HTML, but then it also had to pull down all this stuff. We got the style sheets, and this was a style sheet that we had already loaded for the homepage of the app. It's the same style sheet, but I had to load it again. I mean, it could be cached, and that helps, but still requested it again. So we get a bunch of additional resources that we have to request from the server. Similarly, you may have noticed that when I submitted a review, like let's say I love this strawberry review and I say give it 5 stars and click submit, notice that we're losing the scroll position on the page. We're being bumped all the way to the top. That's because when you do that form submit, it's doing a full page load and you lose the scroll position as a result. We can do better with Blazor in .NET 8. So what I'm going to do is I'm going to go into the app and I'm going to find this is the root component for the app. Notice we got the root HTML doc up here. Everything in this app is being authored with Blazor components. There's no CSHTML files needed. We can do it all with .razor files. And what I'm going to do is I'm going to uncomment this script. And this is the built-in Blazor script, the last Blazor script you'll ever need, right? Blazor.web.js. Okay. And I'm just going to restart. Go ahead.
Quick question. So what you're saying is that JavaScript isn't required to do forms handling?
Well, you can just do normal forms with Blazor, like you saw. Like I was submitting form requests to
without that JavaScript file.
Without that JavaScript. There was no JavaScript involved. It was just old school form requests, right? You route the form post to an endpoint on your server. It runs some code, decides what it wants to do with that data, and then renders HTML to the response.
So maybe no JavaScript was called in the making of this.
In that first demo, there was no JavaScript there at all. Now I've added a little bit. I've added a little bit of framework provided JavaScript, which is going to now enhance that user experience on top of the foundation of static server-side rendering. Okay. So if that worked, if I like navigate around now, I don't know if you can see it, but like there's no blip anymore in the tab. It's really smooth. Like it feels SPA-like. And if we look at what's happening in the browser dev tools, let's say I click on a recipe. There, I just clicked on recipe 1, just like before. But notice there's recipe 1. But where all the other stuff, I didn't have to pull down, the CSS style sheets again. I mean, they were already there. They were already applied. I did an enhanced navigation instead. Notice here that the request type is no longer document. It's a fetch. Blazor intercepted the page navigation, substituted a fetch request. It still did all the rendering on the server, got HTML from the server. If we looked at the, the response to this request, there's all that HTML. But then Blazor looks at that HTML, looks at what's in the browser, and intelligently does a diff, and then patches up the DOM with just the changes that need to be applied. So that's an enhanced navigation, which gives you this sort of fast and fluid feel for navigations on the page without having to push everything to the client. We can also enhance our form posts. Now, by default, if you've watched earlier versions of this demo, we would used to enhance form posts by default as well. We stopped doing that because there are some cases where an enhanced form post might not be what you want, like particularly if that form is going to redirect to some endpoint that isn't a Blazor endpoint, then things can get weird. So it's an opt-in feature, but you can enhance forms as well, and you just do that by going and finding the form. Like here's our edit form for that star rating reviews component, and I'm just going to say, let's go ahead and enhance this too. Let's do the same behavior that we have for navigations, but do it for form posts. And so now if we restart the app and pick a recipe, and let's say, I don't know, kind of meh on this one, and we're going to go ahead and submit that. Notice I didn't jump, like I didn't lose the scroll position anymore. Fast and fluid feel with the updates to the UI when I made that form post. Okay, so we're progressively enhancing our app. If you're familiar with that terminology from days of yore, we're just adding a little bit of client-side functionality to make this app feel smoother, more responsive to our users. So that's enhanced navigation and form handling.
I noticed form name inside your edit form there. Is that new?
Yeah. So form name, where is it? Right here. This guy right here, right? So if you've been doing Blazor before, you might be wondering, like, what is that? Well, remember, to make the form an endpoint, we need some way of identifying it. And we need to know, like, well, which form? Which form is this? So you might have multiple forms on a page. If we submit to a URL, we need to know, well, which form was this supposed to go to? That form name is what we use to disambiguate the form on the page.
Identifier. Yep.
So when you're using static server-side rendering, you need to specify a form name. Good question. Okay, another progressive enhancement is streaming rendering. So sometimes when you're doing server-side based rendering, sometimes you need to do some long-running async tasks in order to render the page. Like maybe you have to go to a database and get some data out of the database, or maybe you need to make an API call, and those operations might take a little while. And while they're happening, the user just has to sit and wait, right? Like the browser's got a spinning wait symbol while you're waiting for the HTML to come down, but you can't get the HTML until that back-end work has completed. So what streaming rendering does is it gives you a pattern that improves the user experience, where you can get pixels on the screen really fast and then stream updates to the page as those long-running async tasks complete. And this is all done over the original connection. Like there's not a WebSocket involved here. You're using the original request connection and then rendering an initial immediate response. So like for example, I'll do a little animation. Like you do a GET request, and to really render the page, you have to do a database query. But you can render the page initially with like some placeholder content while you're waiting for that database query to complete. And then when the database query is done, when that task is completed, Blazor can render that component again to the same connection and render an additional update, a streamed update to the browser. And because Blazor is really clever about being able to patch up the DOM, it can take that new update, figure out what changed, and then patch up the content of the DOM with the newly rendered content. And this isn't a one-time thing. Like if you have multiple async tasks that are happening and you want to render, multiple streamed updates this way, you can do that too. It's not like just one streamed update. You can have N streamed updates as well. Let me show you what I mean. So on the home page for this app, right now it loads lightning fast because it's just like, getting all the data off the disk on my dev machine. So I can hit this refresh button and the page loads almost immediately. But let's imagine that we had to do an API call or a database query to get the recipe data. And to simulate that, I'm going to go into my data folder and I'm going to add a little task.delay to my recipe store abstraction. So this is where we're actually getting the recipes. And now there should be a 1 second delay that we have to wait for in order to actually get the recipes, which should mean that we get a second delay when we're trying to render the page. So if we restart this app now, okay, so if I refresh, ready, click, 1, 1000, and then the spinning stops. It's a little easier to see if I like go to a recipe and then I'm gonna click back, ready, click, 1, 1000, and then the page renders. So now I've got this 1 second delay whenever the user wants to see my site. So that's not great. We can make that better with streaming rendering. Okay, so to enable streaming rendering on that home page, you may have saw it before. It was up at the top. We're just going to add this attribute. So attribute stream rendering. So now the home page will do streaming updates. And if we look at I'll restart the app, but while we're waiting for it to restart, let's look at the logic. So this form is just a little search text box at the top. But you notice we've got this, let's see, I'll do it like this. Okay, we've got this if check. If we don't have the recipes yet, then we're going to render this loading recipes placeholder. And then if we do get the recipes, then we render, remember that unordered list. No, that's not what I want to do. This we loop over all the recipes and render them as cards. And down below, you can see the oninitialized async method. This is the component lifecycle method that loads the recipe data from our recipe store. And what will happen is that oninitialized async will run, and it's going to kick off an async task. And so it will, complete while it's waiting for that async task to finish, and then it will run a continuation afterwards. But immediately after oninitialized async, kicks off that async task, Blazor will go ahead and render our home component. And when it does that, that if check will then kick into gear, and it'll say, well, I don't have any recipes yet, so let's render a placeholder. And then when the async task completes, the component automatically renders again. And that second time it renders, it will render in the else block. And that's when you actually get the content. So you get 2 batches of HTML that will come on the response stream. And so now if we go to the home page and we do a refresh, you see the little loading recipes. I'll see if I can freeze it right there. So loading recipes, ... The page loads instantly. I don't have to wait the second. But then a second later, a streaming update comes to the browser and Blazor automatically applies it to the browser. So that's streaming rendering with Blazor. It's just built-in feature, and you can use it to improve the user experience for your pages that need to run those long-running async tasks in order to render.
Dan, I have a question. This is amazing, by the way, and congratulations on Blazor in .NET 8. It's amazing.
Thank you.
But what if I want to create static server-side rendered content from data in the main page before I go and grab the recipes while they're waiting, before the waiting happens? Can I do that?
So this whole block of code up top, this whole thing is the rendering logic that gets run immediately. Like in order to generate that loading ... all this stuff runs. So if you have things that you can render, like if you have data that's already available or available synchronously, like really fast, feel free to render that HTML content right away. Like this loading recipes doesn't just have to be a p tag. It could be like a whole user experience that the
But
user.
where would you render that if not in the oninitialized async?
Well, sorry, say that again.
Where would you render that if not in oninitialized async?
So oninitialized async is just code that runs before the initial render. And then you have a render before oninitialized async. Well, let's see. Oninitialized async runs, and then the component immediately renders, and then any async tasks that you kicked off in oninitialized async, when those complete, then the component will render again. So all this logic up above, you can render any HTML that you want to in that spot. So in oninitialized async, if you have other code that you wanted to have in here, like generate a bunch of dad jokes or whatever it is.
Hey, speaking my language.
Yeah, then if you have those available, feel free to render the dad jokes while you're waiting for the database query to complete to get the recipes. Like you can just go ahead and render that content.
And then you just do like a state has changed or something.
Oh yeah, okay. So if you have multiple async tasks that you want to run stream updates, then you just call state has changed. So if let's say getting the dad jokes was also an async task, and I wanted to go ahead and render the dad jokes while I'm waiting for the recipes, then yeah, call state has changed. That will manually trigger the component to render, and you'll get an additional streamed update. Yeah, so that's how you get those N updates.
Thank you.
Yep. Okay, cool. So that's streaming. Okay. But Blazor's about like rich interactivity, right? Like building really cool interactive web apps. The cool thing in .NET 8 with Blazor is before your whole app in Blazor was interactive. Everything could use interactivity, but that also meant that you paid for that interactivity across every single page of your application. Like if you were using Blazor Server, Blazor Server would set up a WebSocket connection and state on the server for the application, and that WebSocket connection lived for the entire time that the user was using your app. In .NET 8, you can now sprinkle a little bit of interactivity just where it's needed, like just on a particular component on a particular page, or just one page or 2 pages out of 10, so that you only have to pay for the overhead of those interactive features where they're actually being used. So let me show you what I mean. In this Blazor web app, I have another page other than this, the recipe catalog, which is a recipe editor for submitting recipes. And right now, this page is just a vanilla form. So if I wanted to add like chocolate chip cookies, and I want to be able to pick a picture for my chocolate chip cookies, here's a picture. Right now, all I get is the file name. I'd really like to have like a preview of the picture that I just selected. And then there's this like cool ingredients list editor. Like I'd like to be able to put a bunch of ingredients in here and click add and add them to a list and be able to reorder them and all that, edit them, all that type of stuff. Right now, when I try to click add, it doesn't even do anything. Like, well, why not? Is that because I didn't write any code? No, that's because by default, this page, all it's doing is static server-side rendering. There's no interactive features been enabled for this page, but I can enable those features really easily. And that's what we're going to see now. So let's go to that submit recipe page. So here's the form for that recipe editor, and up top, what I'm going to add to make this an interactive page is an interactive render mode. So this is a new Razor directive in .NET 8, render mode, and there are a bunch of ways that components can render that will make them interactive, and one of them is interactive server. This is like the equivalent of Blazor Server, but in the miniature. Like just for this one page, I'd like to make this one page interactive. Okay. So let's go ahead and save that. I think, actually, before we even do that, like let's even be more granular. Let's comment that back out. Let's just make the ingredients list editor interactive. So we can even put render mode interactive server right here on this one component. So that's just the this guy right here, this ingredients list editor. I'm just going to make that guy interactive. Let's try this again. Okay, and so if we go to the submit recipe page, so now if I go to my ingredients list editor and say, if you're, let's actually type the name of flour right and click go. So now we're able to actually add ingredients. Let's add some, I don't know, 5 eggs and maybe 10 ducks or whatever. It doesn't matter. Like it's a bunch of ingredients, and we can like reorder things now. Drag and drop works. We can toggle between imperial and metric units. This one component is now a little island of interactivity in what is still otherwise a statically rendered from the server application. Like if we go to the home page, let's bring up the browser dev tools. Let's remove our filters. Let's refresh the home page, and let's see. Do we have any WebSockets on the home page? No WebSockets here. But if I browse to submit recipes, aha, now we've got something. Now we've got the Blazor server WebSocket being set up, and we can see that it's active because it's in this pending state. Like we have a live WebSocket connection, and that's what's allowing this one component to be interactive. Like I can do things using that interactive experience. But if I browse away from the home page, watch pending right there. Ah, do you see it? So now instead of pending, it's saying this request had a duration. That's because it ended. It's no longer a live WebSocket connection. We closed the WebSocket connection because we left that page, and all those server resources that we were using to make that page interactive have been freed up. So this improves scalability and allows you to add interactivity just where it's needed. So that's adding interactivity using Blazor Server. I heard a question.
Yeah, so this Blazor component is in the WebAssembly project. But since you added that directive to the top, it runs on Blazor Server?
Yeah, it's so the great question. I'll get to why I put this component in the client project. You'll see you can see here that I have factored this app a bit on purpose to help make this demo flow work. Like this top project is the server project, right? This is the ASP.NET Core project hosting our all our server-side rendering stuff. This client project is eventually what I'm going to want to, the part that I want to push down to the browser. Like I'm going to show now rendering that component on WebAssembly, and the code that will go to the browser and run on WebAssembly will all come from this one project. And that factoring is important because you want to be careful about the dependencies that you add to the part that you're going to build that's going to go down to the browser. Like you don't want to put a bunch of server-side stuff that gets downloaded to the browser that will bloat the size, and you might have functionality that doesn't even make sense from a browser. Like you don't need EF Core usually when you're running in the browser. You can't talk to your SQL Server database when you're running client-side on the user's machine. So this separation helps make sure that whatever code you want to be downloadable and what code you want to stay on the server is really clear.
But now you have submit recipe in the WebAssembly project, but when you change render mode to interactive server, it is running on the server, right?
Everything that the server project references as a dependency, and that project you can see right here is one of its dependencies. It's part of the graph of code that's getting built for the server. So everything in the client project is on just a normal .NET assembly dependency for the server. So I can have components in the client project that I use from the server, and that's fine. In fact, you might even if they're all intended to run on WebAssembly, you might still want to pre-render them from the server, like do an initial static rendering of those components, and then while they're being wired up for interactivity on the client and WebAssembly, like you're waiting for the WebAssembly runtime to be downloaded, but at least you've got pixels on the screen by rendering from the server first. So yeah, you can get access to those components in the client project because they're just a normal .NET library dependency, like a NuGet package or a project.
So he really only separated them out because eventually he wants to show a demo where he's
I'm going to change it to
WebAssembly and
that's
auto.
where I'm getting confused here. So if let's say that is a WebAssembly project, it's getting shipped to the browser, and you turn that render mode into interactive server, does it still get shipped to the browser? Or does
No.
No, it would. So like let's say I let's actually add some let's change this now. So I'm gonna, instead of just doing this one component, I want to actually do the whole page. Let's make the whole page now interactive. And this would make it interactive using Blazor Server. If I switch this to interactive WebAssembly, now this is saying this is a component I want to run from the client, right? Now, if I had another component in the same library, like I don't know, this ingredients list editor, that doesn't really make sense. But let's say I had another Razor file where I put interactive server on it, but it's in the client library. It would go down to the browser. It will be part, I mean, it's just an assembly, right? It'll get built into that assembly, and so that assembly will get downloaded to the browser unless the .NET trimmer, because we run a trimmer when you publish the app, decides to knock it out because nothing's referencing it. Does that make sense?
Yeah. My thought was, I wonder if someone would look at this, and because if it is getting shipped with the rest of the files, even though it says interactive server, that someone might be thinking that will stay on the server and put some code in there that they think isn't going.
But it would. It would. If you looked at the assembly that got downloaded to the browser and looked at the IL, you would see that interactive server component, it's there. It's in the binary because it's being built from this project. So this project separation is designed to help people think about, what code really needs to go where. Like if I have a component that really only needs to be on the server, don't put it in the client project. You can just leave it in the server project. Server-side logic should stay on the server. It's like Fight Club, right? The client project is where you want to put just the stuff that needs to be downloaded to the browser. Me making this component interactive server was a bit artificial, just to show that it can be done. Really, the stuff that would be in this client project would be stuff that needs to be downloaded to the browser to run on WebAssembly. We did experiment for a while with a model of actually having both the client and server project be the same, where we used multi-targeting, where we basically take the one project and build it twice, once for the client and once for the server, kind of like how Maui projects are built, right? Like if you look at a Maui project, it's got like 4 or 5 different targets. Like the same app is being built for Windows and then for Mac and then for iOS and then for Android and maybe Tizen. We played around with doing that with Blazor as well, like having a build for client on WebAssembly and doing a build for server. But because of the way multi-targeting works in .NET right now, it was really difficult to make sure you didn't accidentally bleed stuff from the server into the client. Like it was too easy to accidentally take the pick up dependencies on the client that you really meant to only live on the server. And so we punted on doing that, at least for .NET 8. We still have some hopes that maybe we can get there eventually, but for at least for .NET 8, this separation is important so that you can reason about where the code, what code is going where.
And by the way, sorry for interrupting, but I think that in the works are some tools to help us determine and discern where things are running. And also it'd be great in Visual Studio. This isn't an ASP.NET thing, it's a Visual Studio thing, to have some sort of notifications that, you know, you're running this interactive code without any interactivity, or, you know, this code is going to run on the client, or, you know, do you really want to do this? It'd be nice to at least have some compiler warnings or something like that.
Yeah, I agree. Like that scenario you saw where I had that recipe page, right, where the button wasn't working. Why wasn't the button not working? You can easily hit that and be confused.
Yeah, it's stuff that we would expect the compiler to catch.
The reason why we don't currently raise an error or make that an error case is because by default, all components will pre-render. Like even with Blazor Server today, right? Like with an existing Blazor Server app, when you navigate to the application, it actually renders from the server statically first, and will generate HTML directly into the response stream. And then you get that way the user can at least see some HTML while you set up the WebSocket connection and set up all the interactivity. With WebAssembly in the past, we didn't pre-render by default, but it was supported. Like you could do it where you pre-render from the server while the WebAssembly runtime is being downloaded and setting it up for interactivity, so you at least see pixels while that's all happening. So that means that the components do render statically a lot of the times. So it's not an error to render them statically without interactivity. It's actually a feature. That's how pre-rendering works. So yeah. Teasing out, like, was this a pre-render, or did you just accidentally render this statically and meant it to be interactive is a tricky thing to tease out.
There are some obvious use cases though, like if you create a new project with interaction per page component and you go ahead and set up a button click, but you haven't added the attribute, you know, it lets you compile and it lets you run, and then you click the button and nothing happens.
I think there's more we can do there.
Yeah, there could be at least a warning that says, hey, do you know that this isn't going to happen? And you obviously expect it to.
Yeah, that's good feedback. Yeah, we need to
but it's not for you. It's for the Visual Studio team, I think.
Well, we're all one Microsoft, right? Like we work very closely together.
Did I mention I love freaking Blazor in .NET 8? Okay. Yeah, it's great.
Cool. All right, let's look at WebAssembly. Let's see the WebAssembly case. So I've enabled WebAssembly now, and this already conveniently in the client project. So that's all set up to be built for WebAssembly as well. And let's run that and see what that looks like. Okay, so if we go to the recipe page, this should still work. And it does. And now, because I've actually enabled interactivity for the whole page, right? Like I did it at the top. So now I should be able to do things like, well, actually, let's say like I just submit the page without filling out the fields that are required. And then I start filling stuff out. The chip cookies, and then tab off that. Notice that the interactive validation is kicking in now. If I pick an image for my cookies, I get this little preview of the image showing up on the page. The whole form now is fully interactive, and in this case, it's running on WebAssembly from the client. You know, what we do here: mix and bake. What else do you need to know? I mean, it's really that simple. Okay, so then we're able to submit our recipe. So if we look at how that's working on the wire, so first of all, I'm just going to clear out the cache to make sure that we don't have any WebAssembly stuff pre-cached. And let's see, on the homepage, if I refresh the homepage, do we have any WebAssembly files being downloaded on the homepage? No WebAssembly, but if I browse to submit recipe, aha, now we get a whole bunch of WebAssembly stuff. And there's our .NET WebAssembly runtime, and then all this other stuff too. It looks huge. It's just big because we're in development. Like when you go to publish this app, we'll do that trimming step that I mentioned earlier, where we knock out all the assemblies that you don't need and trim out all the code that you're not using and pre-compress things so it shrinks it way down. But during development, we don't bother doing that so that your developer inner loop is as fast and responsive as possible. Okay, so that's how you can also do interactive WebAssembly rendering. The last trick is auto render mode. In auto render mode, the idea is to try and take the strengths of both the interactive server pattern and the interactive WebAssembly pattern and combine them together to deliver an even better user experience. Like, what if you could initially start out the user with interactive server rendering, you know, set up a WebSocket connection so you get interactivity immediately. That's really quick to do. You don't have to download any big stuff. But in the background, I don't know if you saw there, the little .NET box like flew down in the background. We download the .NET WebAssembly runtime in the background while you're still already set up with an interactive server setup, I guess, in the application. And then the next time the user comes to that page or uses that component, Blazor can detect like, oh, look, there's already a .NET WebAssembly runtime here. Why don't I just use that and save on those precious server resources? And then you offloaded that work from the server to the client. So you're automatically choosing which render mode to use at runtime. That's the auto interactive render mode. Let me show you what that looks like in practice. So for this interactive WebAssembly component, I'm going to switch this to interactive auto. And conveniently, it's already in the client, so that's what we need. And we're going to go ahead and run that. Okay, so now if we look at this app, let's clear out the caches again, make sure we don't have the WebAssembly runtime already pre-cached. And let's refresh the home page. Okay, do we have any WebSockets? No WebSockets. Do we have any WebAssembly? No WebAssembly. Okay, but if we browse to submit recipe, all right, there's that WebSocket connection, right? We've got the Blazor Server WebSocket. It's in the pending state. So that's what's making this page interactive, hopefully. Yes, it is. Okay. But also, if we look at WebAssembly, we can see that in the background, the WebAssembly runtime was downloaded and cached. And then what happens is that the next time, if we like, let's say we browse back to this page in the future, or I'm just going to refresh the page to simulate that. Notice I'm still filtering on WebSockets, but now there's no WebSockets. We didn't set up a WebSocket again. The WebAssembly runtime was already downloaded and cached. And if we try to use an interactive feature, like adding an ingredient, that's still working. And that's because we've shifted from the server to the client. We're now running on WebAssembly. So that's the new interactive auto render mode, kind of combines the strengths of server and client together. So the page can load fast, but you can still offload work to the client. There are a couple of issues with auto in .NET 8 that we're in the process of fixing. So if you deploy with auto render mode right now and you're wondering like, hey, why am I not seeing this behavior when I publish the app? We know, as I think Carl has been helping us out with going through some of this real world testing. Thank you. There's a patch release coming out in, I think it's the January release where we're expecting to get this cleaned up. It's either January or February where the auto mode will be tuned a little bit for real world usage, but that's the idea. All right, cool. So that's the auto render mode. All right, so how do you get started with all this great stuff? There's a new Blazor web app template in .NET 8 that has all these features set up for you. It's set up with static server-side rendering and all the progressive enhancements. You can enable the different interactive render modes, server, WebAssembly, or auto, and you can do that on individual components, or if you want to just enable it for the whole app, you can do that as well. So let me show you what getting started with this stuff looks like. You just got to do File, New Project, Blazor Web App. That's the new template right there. That's the one you want. If you're looking for Blazor Server in .NET 8, it doesn't exist anymore because Blazor Web App is the new replacement for Blazor Server ++, Blazor Server Sharp. It does everything that Blazor Server could do, plus all the WebAssembly stuff in one go. So that's the template you're going to want. We do actually still have the.
Yeah, I was going to say, so if you still do the Blazor Server or Blazor WebAssembly templates, those are for .NET 7, right?
Yeah, so like if I filter in my Visual Studio on all the Blazor templates. I actually have a whole bunch of Blazor templates. Like, what are all these things? So this is the new one, right? Blazor Web App. That's the one we'd recommend really for all your future usage. There is still this Blazor WebAssembly standalone app template that we still ship in .NET 8. What this is a purely client-side Blazor WebAssembly app with no server component. It's basically like a static site. It's something that you could publish to GitHub pages or Azure Static Web Apps without any ASP.NET Core server, anything, and have it work just like, a bunch of JavaScript files and an HTML file. So that's what that one's for. That's for like static site hosting scenario. So that one is still there. You may still see these guys below. And those are the .NET 7 templates. If you have the .NET 7 SDK also installed, you'll still see the .NET 7 template. So this Blazor Server template down here, that's the one that's coming from the .NET 7 SDK. And if you like select it and like, oh, cool, I'm going to create a .NET 8 Blazor Server app, one thing that a lot of people have bumped into is they go to this picker and they're like, wait, where's .NET 8? And the reason why there's no .NET 8 is because there is no Blazor Server template in .NET 8. You should use the Blazor Web App template. If you have the .NET 7 SDK, you'll still see the .NET 7 version of that template. Okay, but going back, we don't want that one. We want the new fancy. So let's create a Blazor Web App. .NET 8, that looks good. And here are some options. So auth options for enabling individual user accounts. Here's where you can decide what render modes you want to enable in the app. By default, we will enable, and by enable, this means like make it available to you to use the interactive server rendering. You can choose to only enable interactive WebAssembly rendering if you know you're only going to do interactive stuff from WebAssembly. Or you can say, you know what, I just want it all. Give me server and WebAssembly, and I want to be able to do auto. Then you select the last option. I'm going to pick the default, which is just server. You can also decide at what location, at what scope you want interactivity. You can say, you know what, I only want interactivity where I choose to have it. I'm going to add at render mode where I want some interactive features, and everything else can just be statically rendered from the server. Or you might know, you know what, my whole app is going to be using all sorts of interactive stuff. I'm basically going to end up making the whole app interactive. So just go ahead and make the whole app interactive for me. This would be the equivalent of the old Blazor WebAssembly or Blazor Server templates where the whole app was just set up for interactivity. I'm going to keep it as per page or component. Also, you may have seen this little checkbox down here, include sample pages. That's the way if you just want to a blank canvas, like you don't want the sample components and Bootstrap and the demoware content in the template, you can just uncheck this checkbox and you'll just get an empty Blazor web app. I'm going to leave that in because we're going to use it for a quick demo. So let's create a Blazor web app. Here it is. And if we go ahead and run this, it will look like a Blazor web app that you may have seen lots of times before. Purple gradient and all that. It's got a home page. It's got a counter. You can click the counter. It goes up. It's got a weather page. Shows a bunch of weather data. But this is running differently than previous Blazor apps. The home page is just doing static server-side rendering. That's it. The counter page is an interactive page. So it has the WebSocket connection. And if we look at the code, let's look at the home page. So the home page, just static HTML, nothing else really going on there. The counter page looks like a normal Blazor counter, but it's got that render mode attribute at the top to say, you know what, this one page I want to be interactive. We'll only have the WebSocket connection, interactive server rendering for this one page. And then on the weather page, this is again doing static server-side rendering, but you can see at the top that it also has set up streaming rendering. So it has a little artificial async task. I'll use the arrow down here, and it's on initialize async method to simulate as if it's going off and doing an API call to get the weather forecast data. And then that allows the placeholder to render. And then after that's done, it generates the weather data, and that's what allows the weather data to then render in a streamed update. So that's how we're getting all of those features in one template. So you got it all right here. You can do interactive rendering, streaming rendering. All the navigations are already set up as enhanced navigations because we've already added the Blazor web script. Yeah, so all the features available with the new template. Yeah, we got still time. Okay, that's the full stack web UI story. So we saw all the features. That's how you can really handle all of your web UI needs with Blazor and .NET 8. Within that one component model, you can build any type of web UI architecture that you want. Now, that's not all we did in .NET 8. We also have a bunch of additional framework enhancements and features that you can use to make your Blazor apps even better and be more productive. Quick Grid is our fast and functional data grid component that we previewed initially with .NET 7. It is now available out of the box with .NET 8. It is stable, so you have a data grid control that you can just use right included with Blazor. Sections is a way that you can define outlets for content in one component that can then be filled in by another component. If you've done any like MVC or Razor Pages development, sections are a thing in the CSS/HTML. Like you define a section in like your layout, and then other pages can like, provide content for that section. Same concept, except now with components. So you have sections available in your Blazor components. We did a bunch of improvements to the Blazor router. We actually like aligned it up with the endpoint routing router in ASP.NET Core, so it now supports all the route constraints and optional route parameters. So those all now work, and we now support routing to named elements. So the routing is much better and improved in .NET 8. We added an API so that you can monitor circuit activity for your Blazor Server circuits, so you can detect when circuits are idle. And we also did a bunch of improvements for authentication across the board in ASP.NET Core. For Blazor, that included adding out-of-the-box Blazor components for handling identity, for building in a default identity UI using ASP.NET Core identity. So I'll show you a few of these things really quick. For this, I'm going to create a new app, and I'm actually going to use, I'm deliberately going to use Visual Studio Preview for this demo, because I'll show you one of the new cool tooling features that comes with Visual Studio Preview as well. So let's create a Blazor web app, and it looks good. And again, I'll select the defaults, except this time I'm going to turn on auth so we can see the new auth support. Right. And there we go. Okay, and I'm going to go ahead and run this app, and this should look just like the other one, except, oh, what? Ignore that. Preview, let's see, rebuild. Is that just because the NuGet package restore hadn't completed, I assume? Okay, yeah, just a little NuGet glitch. Sorry, I clicked build too fast, I guess. All right, there we go. So there's our Blazor web app, and now we've got you see we got home, counter, and weather, but we've also got a few extra tabs on the application. We've got this auth required tab. If I try to click that, I get bounced right over to the login page. That's because in order to view auth required, I need to be logged in. And I don't have a username and password set up yet, so let's register as a new user. And we can go ahead and do that. Let's type in my password, that password. And then I think because this is a new app, yeah, I have to run migrations on the database to apply the identity schema to the database, but we got a little button here that will just do that for you. Refresh the page. Cool. I just registered a new user, and I can, I need to confirm my email, and during development, you can just click this link in order to do that. Now I should be able to log in with my new user account. I'm logged in, and now if I click on that auth required page, I can see the protected content, and it knows who I am. There's also this user account page, which has all the stuff for looking at your user profile, changing your email address, updating your password, setting up two-factor authentication. It's the full ASP.NET Core identity experience, except all this UI now is built using Blazor components instead of, I think Razor Pages is what we used in previous releases. The Razor Pages default identity UI is still available if you're using it. You can still use that, but for Blazor apps, you now have a full Blazor-based solution. All of the components for the identity UI experience in this app is under this accounts folder. You can see all the components here. And these are all just static server-side rendered components. So you can customize this code and adjust it to your application's needs. So that's authentication.
Dan, question?
Yeah.
So all the scaffolding that we used before to add identity to a Blazor or an ASP.NET Server application, is that all redone for Blazor for all ASP.NET pages?
So there is an identity scaffolder that ships with Visual Studio, and that identity scaffolder is still the Razor Pages based scaffolder. We haven't built the Blazor version of that scaffolder yet, but we will. Like that's in the works. It doesn't look like it's going to land yet for 17.9 of Visual Studio, but probably by I think like middle of next year, so you should expect to see a Blazor identity scaffolder where you can generate these components into an existing app.
Well, if you need help with
Oh,
it,
the only way to get them is by creating a new project, and if you need them, you have to like copy and paste them into an existing app, which I know it's kind of like the identity UI that we had like 5 years ago in ASP.NET Core before we added the scaffolder. We just haven't gotten the Blazor scaffolder done yet. But
oh, it's so much better to have Blazor pages on the client than have to go to the server to do the login and stuff. That's great.
So that's a different interesting point. So these pages are all still actually static server-side rendered pages. Like they're interacting with the identity UI,
Okay.
sorry, the identity APIs from the server because they're running from the server. So they're set up to be static server-side rendered pages. They're not actually set up to be moved completely onto WebAssembly. We haven't built a fully client-friendly version of these Blazor components. That would mean like doing API calls to like access the user information and setting up the user account, which these pages don't currently do. If you feel a strong need to have a full client-side solution for your Blazor Identity UI, let me know, because that's something we haven't actually completed yet, but it's something we could consider.
I was going to ask about that. So these are all statically rendered. That's how you're able to put the cookie into the browser.
Yeah, it's just doing cookie-based auth, and it's doing it all from the server. It's interacting with the database directly from the server. I could see the look of disappointment in Carl's face. He's like, "No, I thought
no, that's fine. That's fine. The best part is I get to contain it all and I get to customize it to my desires, right? For my
remember,
brand
like,
and etc.
Blazor web apps now, like they're a mix of all the, like you can use any of the render modes together. So you can have still your app be a Blazor WebAssembly app, and the identity parts are all being just static server-side rendered pages, because for a lot of them actually it makes a lot of sense. Like most of them are just, there's not like a lot of drag and drop and like button clicky things that are happening on the identity pages. So the user experience for them is snappy, it's fast, it loads quickly. So for a lot of those pages, I would argue actually it makes sense.
Yeah.
Cases where you might want a full client-side experience is like, well, I want to deploy this to like a static site host. Like, how do I do this on like GitHub pages, or how do I do this from an Azure Static Web App, that type of thing. In those cases, you might want the flexibility to be rendered the UI from the client, which I would understand.
But a moment's thought, and you realize that, wow, this is hard. So I need to have an authenticated API to call into my login page. However, I'm not authenticated yet.
Yeah.
That's a real tricky situation.
Yeah, you'd have to, you have to have a login endpoint. Actually, the login endpoint can't be authenticated. That would have to be something that would allow anonymous access, but that's the endpoint you go to and make an API request to acquire maybe a token. We do have in ASP.NET Core in .NET 8 new identity endpoints that we do provide now as part of ASP.NET Core. As part of ASP.NET Core identity. So these are programmatic endpoints that you could call from like an Angular app or a React application, precisely for this reason. Like maybe you want to do client-side management of identity. You can do that. We just haven't built Blazor components that follow that pattern, because we haven't really felt the need to, because you can mix the static server-side rendered pages with your pages.
Ultimately you have to call a server to log in anyway.
Yeah.
So you might as well render it from the server.
But
the key is to be able to control the UI and to control what the user sees and, brand it to you. Like, I love the fact that it's right in your Blazor app. It's a page. It's not an outside, CSHTML page.
And it's also all within, it is still the Blazor component programming model. Like the way you interact with these are all Razor files. You're not having a mix of, CSHTML and .razor, or .razor and JSX files, or whatever it is that you're using. If you're using client-side JavaScript, you get to operate within one model for how you're building all of your web UI. You're just deciding like how those components then render, what render mode you want to use for those components.
Yeah, great. Before we go on, is there any love for Azure AD B2C that is different in .NET 8?
Yeah, so you may have noticed that in the auth dropdown for the Blazor web app, the Microsoft Identity Platform option is currently missing. We didn't get that done in .NET 8. It's just, we did a lot in .NET 8, but there's still, of course, there's always more to do. We are in the process right now of building out the Microsoft Identity Platform samples for Blazor web apps, for how do you use Azure AD and Azure AD B2C from this style of Blazor application. And we will add tooling so that you can just, select the option, have it wired up for you, or do add connected service and say, please add Microsoft Identity Platform to my existing app. Those features are coming. They just didn't get done by November.
Brilliant.
Let's see also adding some data. So this is the reason why I picked Visual Studio Preview, because another cool feature that you have available to you in preview form is, let's say I want to, actually, let me add a model type. Let's add the famous movie type from the movie tutorial. Let's, I think I've got it right here. Yeah, here's movie CS. So this is just a simple entity data model. It's a movie with an ID and then title, release date, genre, and price. And what I want to do is I want to generate some Blazor pages based off of this this movie type. Well, we can do that by just right-clicking, add new scaffolded item, run Visual Studio scaffolding tooling, and pick Razor components. And I'm going to use the new Razor component using EF Core CRUD scaffolder to generate these pages. So let's select that. And here I can pick which templates I want to generate. I can pick individual, create, read, update, delete pages, or I can just select CRUD, which will generate them all. I pick my model type. Let's find my movie type in here. There it is. Pick my DB context. I already have one because we set ourselves up with identity, and just go ahead and add that. And instead of having to write a bunch of EF Core code for my Blazor components, I'm just going to let Visual Studio do that for me. That should generate me result in build errors. What errorless? What build errors? I've never seen
a
that.
demo without one of those, Dan.
I know. I've never seen that. Well, it looks like it worked. I don't know what that was. Preview feature. So, some bugs may still exist. I just generated all these pages for me. And I also want to be able to store my movies in the database. So I need to also run a migration to apply the movie schema. So let's do that real quick. Let's do add migration, movies, and then update the database with the migration. There we go. Hopefully some telemetry got sent from Visual Studio for that build failure so that the devs working on the scaffolding feature can finish fixing it up. Okay, so now if I run this, oh, looks like it's already running. Yep, still running. Go to, and I didn't add a link to it, so I'm just going to browse directly to /movies. We've got a little movie set of pages that we can use. So I can create a new movie. Let's add a movie. I don't actually know the release date for ET. I looked it up at one point for this demo, but totally forgotten it. Sometime in the 80s.
1980 something.
I only do movies from the 80s because that's when all the good movies were. Sci-fi, I don't know, $8.99 for the price. So we've added a movie to our table. You can view its details. You can edit the movie. Got a little form here that's been generated for us. Back to the list, and we can delete movies as well. So we now have, basic CRUD pages for connecting to data from our Blazor components using the new Blazor CRUD scaffolder. And what's neat is this isn't just a vanilla table. If we look at the index page that got generated, let me give myself a little bit more room here. About doing it like that. That home page, this index page, is actually using QuickGrid. It's using our new data grid component for generating that table. And this supports all sorts of really nice features for displaying and manipulating your data. For example, let's do a bunch of edits here. This release date doesn't look like, it looks like it's just pulling it from the property name. We can update that. Let's change that to release date with a proper space in it and go ahead and hot reload that into the running application. Boom, done. This date looks a little verbose. Let's format that a bit to month, day, year, and save that. Boom, there we go. We can add sorting. Let's do sortable equals true. And now you should see that the title See how the title is selectable now, and I can click on it. Of course, we only have one movie. Let's is that another movie? I think I did Labyrinth.
While you're editing, Dan, Kelly brought it up. It's June 11th, 1982.
I was close. I was close. I don't know.
Pretty close.
Labyrinth is. They're all in the summer, right? All the movies get released sometime in the summer, or at least summer in our hemisphere. This one's 1980 something, and the genre for Labyrinth is, I don't know. It's weird. It's say adventure, I guess. This movie gave me nightmares as a kid. That's why I like putting it on here. Now, let's say if I can sort now, and it's still not sortable. Why is it not sortable? That's because, remember, by default, Blazor renders pages statically. It's doing static server-side rendering. So it's not an interactive page yet. And this is where Carl would say, Dan, there should be a warning there saying that you're using an interactive component.
Yeah,
And,
it's not that there should be a warning. It's just that this is the new normal that people have to get used to. That if they don't put that interaction attribute there, it's not going to work.
I don't disagree.
Yeah.
So let's make this component interactive. Let's fix that. Interactive server. And I think I have to restart the app in order to get that to apply. I've got a bug filed about applying interactive render modes using hot reload. It's not supported yet. But now if I click on this, you can see I can change the order. That's how easy it is to add sorting. We have a paginator that's included with the with QuickGrid. Let's add a paginator component. I'm getting a little warning here. The paginator component expects a value for the parameter state. And I broke because I accidentally saved and applied it to the running app. So that was a hot reload letting me know that that's not going to work. So I need to add a state parameter here. What is the state? The state should be a pagination state. So let's just add a little code block and add a pagination state object down below. And this is where we specify how many items do we want per page. Since I only have 2, we're going to make the items per page 1. And let's go ahead and add that state right here. This is also the state object that the paginator uses to coordinate with the QuickGrid. So you actually also have to say pagination and then apply pass in the state object to the QuickGrid too, so that it knows about both. Okay, and looks like we are back in gear, and now we've got a little paginator widget at the bottom, so we can, is it not working? There we go. So I can click back and forth and see my 2 pages. And you can add filtering, you can add virtualization. There's a really nice demo site for QuickGrid at aka.ms/blazor/QuickGrid. Just go there. There's a little GitHub Pages based site. It's actually a Blazor WebAssembly based site that has an example of QuickGrid. We all the things that we showed, sorting and filtering, filter to Canada and see how Canada does in the Olympics. Clear that out and so forth. You can connect to various data sources. It supports virtualization. So this QuickGrid is actually rendering 22,000 rows of data into this grid, and it's rendering them as they become visible. That's how virtualization works. So that's supported right out of the box. You can style it however you want. Make it look super professional, and so on. So it's a very fully featured QuickGrid. If you really want every bell and whistle, QuickGrid might end up being a little bit too feature poor for your needs, and in those cases, we would recommend going off and checking out the commercial grade data grid components from Telerik and Syncfusion and DevExpress and so on. But for many common scenarios, QuickGrid is quite sufficient. So that is QuickGrid, the new identity UI, and the new Blazor CRUD scaffolder as well. I know I'm a little bit over time, so I think we'll stop there. A couple other quick things that I just want to call out before we wrap up. WebAssembly execution in .NET 8 is much improved for .NET code. We have a new JIT-terpreter-based runtime in .NET 8. And what this is it's the .NET runtime that you download to the browser to run your .NET code. In the past, it didn't have any JIT support. It couldn't take your .NET IL and convert it to WebAssembly on the fly, like you would expect a server runtime to do. A server runtime will take your .NET assemblies and will JIT them to native instructions for your underlying platform. We didn't have that for WebAssembly for a long time, but in .NET 8, we now have a partial JIT support for our .NET WebAssembly runtime, and that makes it run much, much faster. So, 20% faster UI rendering, JSON deserialization is way faster. It's like twice as fast. Significant runtime performance improvement for your code running client-side in the browser. Hot reload in .NET 8 is significantly improved. We support new hot reload types of edits. You can now edit generic types. And also the hot reloading to a WebAssembly-based app now supports all of the edit types that were supported for server-based workloads. So you have full parity on the edit set, and we continue to do work to push back that frontier of what works with hot reload. I just got an email today about capturing lambdas now supporting a hot reload, which is huge for Blazor. Like if you've ever had like a child content or a templated parameter, like you're using Mud Blazor or whatever, and you've got a bunch of content inside of a component tag, and that never worked with hot reload because it's a lambda that's capturing some state, and hot reload didn't support that. That is coming, and that's going to be way better. So this is a constantly improving bar, the hot reload experience. If you're doing ahead of time compilation, like taking your .NET code and just compiling it directly to WebAssembly as a build step, that's also much faster in .NET 8 thanks to SIMD and exception handling support being turned on by default. We have a new packaging format for WebAssembly-based apps called WebCIL. We got a bunch of feedback from Blazor WebAssembly users that in certain environments, their apps get blocked by like firewalls or security software because they see a DLL being downloaded across the network, and they're like, no, and they just stop it. And Blazor is based on .NET assemblies, which are DLLs, and so they would sometimes get blocked in very restricted environments. In .NET 8, we have a new packaging format for your assemblies that strips off all of the Windows native executableness of your assemblies and just makes them into packages them basically as WebAssembly files to avoid that problem. As far as we've heard so far, this has had a lot of success. That people are we haven't heard any problems yet with the new packaging format, which is very promising. Also, we have improved our content security policy compatibility with Blazor WebAssembly apps in .NET 8, so you don't have to enable unsafe eval. If you're, you can render components outside of an HTTP request now. Like you can just take a Blazor component and render it to a string or to like a stream, like a text file, without having ASP.NET Core in the picture at all. This is useful if you want to do like templating of content, like you want to generate some HTML just using Blazor components as your templating model. This is laying some foundational work for static site generation support post .NET 8. It's pretty cool. You can should check it out. You can basically build a console app that just renders Blazor components to text.
What's really good about that, if I may, is let's say you have a podcast. I don't know, anybody who would have a podcast, and you update your content once a week. So your page updates once a week. You could render that on your desktop to HTML and then just copy your HTML up to Azure or AWS or wherever your static site is, and you're done. That's it.
Yeah, that's the. In fact, that the QuickGrid website is actually a bunch of the pages of that site are statically generated. Like we just pre-generated them using from the Blazor components at build time using a community solution from Jay Sakamoto, who he built a Blazor static site generation solution. We're hoping that with this new capability in the framework, it'll make that type of static site generation easier and more first class. Probably actually, I think needs to be a framework feature of something that we just provide. I just show it real quick. It's real fast demo. So where is it? Let's get off preview VS.
Go for it.
And let's bring it up. Here is this. Here's our HTML. So this is just a console app. Oh, Solution Explorer is hiding. Okay, so this is just a console app. But it's using the new HTML renderer API. So that's the thing you use to render components wherever you like. And then down here below, we are calling a render component async and just pointing it at our component type that we want to render. The only thing that's kind of interesting and tricky here is that you need to render components in the context of a component dispatcher. So that's what this invoke async call is doing. It's sort of setting up that context so that we can then call render component async. But then you just render a component. So here I have a Razor file, just a simple little component. And if we run this, we can render a bunch of HTML to the console output without any async or any HTML context in the application. So I'll put that sample in the chat in just a bit so you guys can play around with that. For people that have existing Blazor apps, just want to clarify that you can just update your existing Blazor Server and Blazor WebAssembly apps to .NET 8 without changing any code. Just retarget to .NET 8, update the NuGet packages, and that should just work. If you found that's not true, let me know, because that should be true. It's a bug if it's not. So it was Steve that you were upgrading from .NET 7 to .NET 8. That from a Blazor perspective, that should have been silky smooth, super seamless. That's the intent. If you decide you also want to move to the Blazor web app pattern to take advantage of the new full stack web UI features, that does require some code changes, but that is doable as well. We have docs in our migration guides that show you how you can evolve a Blazor Server app to be a Blazor web app, or evolve a Blazor WebAssembly app to be a Blazor web app. If you're not using Blazor, you can still start using Blazor. Like if you have an MVC app or a Razor Pages app, you can add Blazor components to your existing application. Like you can just add Blazor component-based pages alongside your MVC views or alongside your Razor Pages. You can even render Blazor components from your CSS/HTML files. There's a tag helper that we provide even before .NET 8. Like it was available in earlier versions, where you can just take a component and render it from a CSS/HTML file. That's already supported. In .NET 8, we did add a Razor component result, which is an iResult that you can return from like a minimal API or a MVC controller to just render a component as a result of an MVC action or in response to a minimal API request. And you can also always render a Blazor component from any web application. And I mean any web application, by just rendering them as custom elements. Blazor supports the custom elements, which is an HTML standard of defining custom tags at like the JavaScript layer. You can register a Blazor component as a custom element, and now that component can be rendered from a JavaScript-based app, like an Angular app or a React app. You can even technically render them from like a .NET Framework app. Like if you have a web forms app and you want to render a Blazor component in it, register it as a custom HTML tag, and you can do that if you use the WebAssembly-based hosting model. So lots of ways that you can integrate Blazor into your existing apps, even if you're not using Blazor today. And with that, I'll just bring up, this is the summary of everything that's new in .NET 8, all the full stack web UI features that we went through, lots of framework enhancements, quick grid, generating static HTML from components, sections, and the auth support, lots of improvements on WebAssembly as well. So we are deeply invested in Blazor. We think the future for Blazor is bright. I would say that these days, if you're building a web app with .NET, my recommendation to you is you should use Blazor to build that web app. That is the recommended solution. Obviously, lots of people have MVC apps and Razor Pages apps, and they'll continue to develop those. And if you have lots of engineering investments in those frameworks, that's totally fine. They're not going away. They're still absolutely supported. But for a new app, I would absolutely recommend using Blazor for your web app development, because you get the full end-to-end web development experience all within one framework. And you should give it a try today. Download, install .NET 8, build your first Blazor web app. It's loads of fun, and let us know how that experience goes. And I will stop there. I think I went a little bit over time. Sorry about that, but I'm happy to stick around and answer some questions.
Dan, real quick, I don't have a question, but I have a comment. I was talking with Jeff Palermo today, who is one of the early adopters of ASP.NET MVC. I remember interviewing him on .NET Rocks as soon as MVC came out, and he is fully in the Blazor web app .NET 8 camp now. He had done a couple of, or at least one Blazor app for a client, and then seeing what's going on in .NET 8, he's like, well, there's no reason to start a new project with anything but a Blazor web app now. So that's cool.
It's great to have Jeff as a happy customer. I was just chatting with Jeff actually a few days ago. We did a podcast together on his Clear Measure podcast, and yeah, we were talking about some of the apps that he's built. Like I know he built an auction-based app for a while, like during the pandemic years, where he was able to help like state fairs do like remote auctions using a Blazor server-based application. And yeah, it's cool to see some of the stuff that he's done. Oh, thanks, Sean, for
It
putting that
just
in.
reinforces the idea that, you know, your go-to start greenfield template should be Blazor web app in .NET 8.
So I don't think it's possible for you to go too long, Dan. This was a great talk. I really appreciate it. The demos were awesome. Question just came in. Could you speak a bit about offline first database development? Any work being done about local data caching during intermittent connectivity and then syncing back to the server when connectivity is restored? Perhaps it would be greater need more with hybrid Blazor Maui apps.
Okay, yeah. So like where you have data on the client and you need a synchronization solution. So like you might have built a PWA with Blazor, which means that the Blazor files can be downloaded to the browser and cached, and you have service worker and all the infrastructure in place, so that app can actually run offline. And you might be collecting data with that app, and then later you need to sync it up to the server. We haven't done anything in the .NET platform to assist with that scenario. We do have support for, well, so in the browser, you have a bunch of data storage solutions, right? Like there's IndexedDB, there's local storage. So you have different options in the web platform for storing data. And then in order to interact with those storage mechanisms, you typically need some amount of JavaScript interop today. Like Blazor doesn't provide APIs out of the box for like interacting with IndexedDB, but the community does. Like there's NuGet packages out there that you can use that provide like a .NET wrapper around those local storage mechanisms. Carl, do you have one?
I do, yeah. If you look at Blazor Train episodes 80 and 81, and the GitHub repo that I posted in the chat, I've actually created a repository that will include IndexedDB. So rather than having to write SQL statements, you use a repository pattern. So you've got a basic interface to do CRUD stuff. And when you use the IndexedDB repository with the same interface that you'd use for API calls or Entity Framework or whatever, you can write to IndexedDB, and it does syncing to the server. It may not be perfect, but it works on my machine. That's
for the sync logic for synchronization. Like I know that's one of those tricky problems, like with inconsistencies. Did you write your own thing, or did you end up using like some sync framework?
I wrote my own synchronization. Yes.
Okay. So Carl has one. Use Carl's thing.
Well, I haven't gotten a lot of feedback on it. Some people have said it works great, and I think it works good. But the whole idea, like you said, is that when you're offline, you're logging these transactions, right? I added this record, I deleted this record, I edited this record, and you're working on IndexedDB. Then when you go online, poof, it syncs automatically, and all of those transactional actions get updated.
Yeah. So I know I know there have been other like I think Microsoft for a while shipped a thing called the Sync framework. And I don't know what happened to it. I remember years and years ago seeing it being advertised, like back when I used to working on campus, back in Redmond.
I remember that.
Advertising.
Yeah, the problem was it was sort of it was tightly coupled to SQL Server, I think.
Was it? Okay. Yeah.
I think. And this is an interface. It's a repository pattern, so you can use whatever you want.
So that's what I would look at. So do we have anything in the .NET platform? No, like we haven't tried to solve that as provide an out-of-the-box solution for that. But I would look to things in the community, like what Carl was mentioning, to solve that problem. The fundamental pieces that you need for it should all be available to you.
Right. Pretty cool. Another question came up because apparently somebody's very hungry. The food app that was you demoed, is that available someplace where maybe on the is there a GitHub for that, or is that already posted out there?
I'm putting it in the chat right now. I spent some time before this presentation, finally getting that repo updated so that the main branch is actually the .NET 8 version now, and cleaning things up. So yeah, that's the repo with the recipe app. There are a couple branches of it. Like there's a Blazor Server version, there's a Blazor WebAssembly version that are older. I don't think I updated those to .NET 8 yet, but the main branch should now be the Blazor web app version.
Okay, very cool. Is there any way to, from the browser, to get the current state, like appearance, of a Blazor app as static HTML with no interactivity?
Like capture the HTML of this screen. Get the current state of a Blazor app as static HTML. I want to build a POC, render the HTML, handle it to it. Tell them, make this look pretty, then hand it back. Well, I mean, you can always just like Control U and like just view the source of the page and then hand that over. So the browser will give you the HTML that was rendered from the server. If you're looking for some like tooling that will export it as a file, I mean, I'm sure there's some APIs in JavaScript where you can just capture the DOM and then try and generate the HTML version of it. I'm less sure about that. But certainly just like using the browser dev tools, you can pretty easily capture the rendered HTML from the browser. James, I don't know if that helps. Is that
Well, it usually just gives you like the simple block with everything else, everything the Blazor is going to put into there. So you just get to like the one dev with the app, ID app, and
yeah. Well, I don't know. So in terms of automatically doing, certainly from the browser dev tools, you can grab the content. You could. I'm trying to think of what else. How else I would do this. Like those ways, sort of export what it looks like. I think the easiest thing, honestly, is just render in the browser and then like use the browser features to get the content. That's the best thing I can think of. If people on the call have other ideas, feel free to chime in.
I've never seen
Okay.
anything like that.
All right. Any other questions?
Something I would like to see is a Microsoft supported NuGet package that has all the interfaces to the JavaScript APIs.
Yeah.
So if you wanted to do, call the document API, or wanted to call media recorder or something,
Full
like,
coverage.
like code
right?
generation that generated all those interfaces and just ready to use. I mean, it would be fantastic.
What's the matter? JavaScript not clear enough for you?
Well, I mean, I'm fine. I will write the TypeScript files, but lots of times I find that I'm just writing essentially an interface to the JavaScript API.
Yeah.
Dude, I feel your pain. I feel your pain.
So originally that was the idea. Just never quite came to full fruition because the runtime that Blazor, particularly on WebAssembly, is based on is the mono-based runtime. I mean, it's all honestly these days, like it's all just one big .NET runtime team, and they just have different runtime implementations for different platforms that we care about. The fact that it comes from the mono heritage is just basically history to us at this point. But that's where its origins came from, and the people who worked on the mono runtime were from like Xamarin, the Maui folks, and they had a culture of like when we go to a platform, we build tooling to generate bindings for all the platform APIs that we care about so that you can easily call them from .NET. So when we were doing Blazor in the early days, there was projects through tooling generating bindings to the JavaScript APIs from .NET. And I'm guessing there's probably still some branch and some repo kicking around someplace where this effort started. It ended up we ended up scoping back from it. Part of it was because we were nervous about shipping it and having them not be very just not very usable. Like often machine generated bindings can be a little bit rough, a little bit more for machines than for people. And we saw a lot of value in sort of human crafted JavaScript interop libraries that really, satisfied people's end user scenarios as opposed to just being something you generated from TypeScript definitions. So we were worried about putting out a whole bunch of APIs that ended up not being, having very good, what's the word I'm looking for? Just not having very good usability characteristics. So we paused on it, and then we just never resumed. I think there have been a couple efforts over the years to like generate tooling from the community to generate tooling that would generate JavaScript interop bindings based off of TypeScript definitions. I think David Pine worked on something along those lines for a while. I'm actually a little surprised that no one in the community has just been like, you know what, I'm just going to do this. I'm just going to build a tool that sucks in all the TypeScript definitions for all the JavaScript APIs and spews out a whole bunch of packages and just call it good. Someone wants to try,
Maybe
like
make it a NuGet package, because I don't really need the code generation to happen on my end. I just need the
right,
final.
yeah. If someone just build the tool that can generate do the code gen for all the NuGet packages that then people can just like use those interfaces.
Yeah, just get that file and then use it. Because if you go to a TypeScript file and you control click on, say, the media recorder, that TypeScript file that it takes you to isn't that big. I mean,
yeah, no, I agree. It's on the backlog of things that I think would be interesting to still tackle. I think we had hoped also that by enabling the community, like that there would just be enough NuGet packages that would be built up by the community that it wouldn't be needed anymore to actually have Microsoft ship these libraries, that we would just have a good ecosystem of them. And we do have a pretty decent ecosystem of JavaScript interop libraries, but they have varying, it's kind of like, it's a little bit like the JavaScript ecosystem as well, right? Like there's a lot of packages, they have varying levels of quality, varying levels of maintenance on them, and the coverage is still pretty patchy. It'd be nice just to cover everything. So good feedback. I'll take that back to the team and say, can we do this finally?
yeah, it'd be amazing, I think.
I suspect there's also a like interchange type benefit from doing that. Like the people that work on the core framework libraries in .NET have this notion of like, key interchange types, like data types that represent chunks of data that often involve interactions across different systems. And you really don't want to have that type, have multiple versions of that type. You really just want to kind of everyone unify on this is the type that we use to represent a GUID or a string or, whatever it is. I suspect by normalizing the API set for what it means to interact with the web platform through .NET, that will enable a much richer ecosystem on top. Like everyone knows, like, oh, the way you interact with the storage APIs is using this common storage abstraction, kind of like the way you interact with a file in .NET is using the common file abstraction. There's not like 5 different ways of interacting with a file. There's just one. I'm guessing that would help that ecosystem build up a little bit quicker and more nimbly.
This has been an amazing discussion. Very cool. Yeah, Chuck, have a good evening. Yeah, thank you, Dan, so much. I greatly appreciate you coming out and doing the talk for us. And this has been awesome. Greatly appreciate it.
Thank you for having me. Thank you for letting me participate in your community and your user group. Don't be strangers. If this doesn't have to be the end of this conversation, like you can find me on Twitter or X or whatever it's called these days. I am on Mastodon as well. You can always, of course, find the entire team on GitHub if you have questions or if you had issues. Like, just go ahead, open a GitHub issue, start a conversation. If you have ideas on how we can make Blazor better, we also want to hear those there as well. So feel free to share your proposals, get something started with not just us, but with the rest of the Blazor community.
Thank you, Dan, to you and Steve and the entire Blazor section of the ASP.NET Core team. This is an amazing technology. And 3 years ago when I first got wind of it, or 4 years ago now, I knew it was going to be the stuff. And to see it come to fruition slowly, and now, it's the de facto way to build .NET Core, ASP.NET Core websites. It's just amazing. So congratulations and thank you.
Thank you. It's amazing to see how far it's come. Yeah. And yeah, it's not new anymore, right? Like I know sometimes I still hear people say like, oh, Blazor's a little new. I'm like, no, it's
No.
not. Like we shipped Blazor back in like, 2019 was when it first shipped the first stable release. The first like preview releases were like 2018, even back in 2017. So this is a pretty mature framework now. The ecosystem's built out, the
It's
experience is
proven.
built out. So I think you're in good company if you're building your next web app with Blazor.